Hello, my name is Wenhan. Now let me start my presentation for SDR520 course. Topic is programming in RobotC. I will introduce three labs which I created in this semester. In the end, I will do the summary, what I learned from the course. SDR means software designed for robotics applications. Through the study of this course, I have initially mastered the ability to write simple programs on the RobotC Robot Virtual Worlds VX 4.x platform to control the three robots. They are VX Square Boat, VX Sphere Boat, and the VX Clawbot to automatically run and execute commands as required. This course also made me interested in RobotC, robot programming. In the future, I will continue to learn and practice robot programming skills. First is Lab 1, Mobility. In this challenge lab, I designed and implemented the software to autonomously move the VXEDR robot through a predefined labyrinth. Learning outcomes here. Upon successful completion of this challenge lab, I demonstrated the ability to create and load an autonomous application using RobotC on the VXEDR Cortex controller. Implement the concept of mobility. Use integrated encoder models to track accuracy within robotic mobility. Specifications are here. My task is to write an autonomous software application using RobotC that will successfully navigate a labyrinth course. The robot should start at the starting point and stop at the end point. The robot must first begin at the starting point and get to the goal area by completing returning and forward movement behaviors. I'm not allowed to control the robot in any way once the program has started. My robot must be programmed to stay within the lines of the labyrinth. I'm free to be creative in designing my labyrinth. However, it must be follow the base design provided by professor. Here is my code. I will introduce it some later. Now you can see I use the main function to solve the solution, created the program. Now, please, I will show my record video for lab 1. This is the RobotC platform and use the virtual robot to run my program. I choose the VX Square Boat model robot. This is my I created the map. I draw the map. The robot go out the start point and turn left, move forward, and turn right. Continue. turn right, continue to the end point, and didn't touch the wall. Successful. Now let me show you the important point I learned from this lab 1. First is robot waits for 1000 milliseconds before executing program. I use wait 1 second 1000 this this code, and the motor on point 2 is run at 127 power forward. I use this style, the same as for the left motor, and similar as this one, it's set 4500 milliseconds. And turn left, this is a left motor minus 80. The 80 is the power, same as here. If the left motor is minus, that means turn back. Right motor go move forward, that the robot will turn left. The same as turn right, just to change it. Move forward is the two motor, left and right, just move forward. Continue 1000 milliseconds. Now it's here is the lab 2, multi-sensor autonomous. In this challenge lab, I designed and implemented the software to autonomously move the VXEDR robot through a set of predefined challenges. Learning outcomes. Upon successful completion of this challenge lab, I demonstrated the ability to demonstrate an understanding of robot sensors, implement the autonomous sensor control, detection, and reaction, use multiple sensor devices simultaneously in a single autonomous application. Specifications. My task is to write an autonomous software application using RobotC that will successfully perform the following objectives. Drive forward and find a line on the floor. Follow the line to the end. And stop when the wall is detected. I use the following sensors: sonar and line following. Here's the code, similar as lab 1, but created some new functions here, like use the if loop. Check the line following sensor's value large 1000 or not. If yes, do the if loop. And here is the move forward, turn left, and excuse me, move forward, turn left, and the robot will stop while loop if sonar sensor's value smaller than 20 and larger than 0. That means the robot, if the robot can move forward and found the wall is in the front of the robot, the sonar will find the value, and if it's smaller than 20, that the robot will stop. The robot will turn left if left line following sensor values larger than 1000 until midline following sensor value equals 1000. That means if the robot move on the line, it will turn left, turn right. So the line following sensor will check the value. If the robot is this way, the right right line following value will larger than 1000. That means the line is in the right side of the robot, so it will change the way to turn right until the line in the middle. Set the same as this one. If yes, the same, and go straight. And at the end, the robot stopped the left and the right motor. Now, let's watch the record video for lab 2. The robot will go out from the start point, and find the line. Use the line following sensor, and the robot will move forward, following the line until the robot found the wall in front of itself. Use the sonar sensor. Okay. Now let me show the important points what I learned from this lab. First is I learned the if loop to check line following sensor value large 1000 or not. If yes, do the if loop. Turn left until the middle following sensor value equals 1000. And stop robots left and right motors here. Robot will stop while loop if sonar sensor value smaller than 20, the larger than 0 is this one. And robot turn left if left line following sensors value larger than 1000 until mid line following sensors value equals 1000 here. The last lab 3 is a multi-sensor autonomous control. In this challenge lab, I designed and implemented the software to autonomously move the VXEDR robot through a set of predefined challenges. Learning outcomes here. Upon successful completion of this challenge lab, I demonstrated the ability to demonstrate and understanding of robot sensors, implement the autonomous sensor control, detection and reaction, use multiple sensor devices simultaneously in a single autonomous application, and use a manipulator. Specifications. My task is to write an autonomous software application using a RobotC that will successfully perform the following objectives. Drive forward and find a line on the floor. Follow the line to the end. Stop when an object is detected. Pick up the object and turn back to start. Drop the grasp object. I use the following sensors: sonar, line following, bump or touch. Here is the code. Expand some functions, and also I used the turn left function like here, go straight functions, turn right functions. It can be reused in the main function. Here I also set the two global variables. It will be used to control while loop in the later. And the TF, that means true or false judgment 1. TFB means true or false judgment 2. Yes, I used the unit function, turn left here, like here, and continue 1020 million seconds, and go out the start area. And if the mirror line follow sensor value large 100, go and turn left. The value is was changed because when I ran this lab 3, I changed the laptop and the environment was changed. The value also changed, even though it's only the same line, the black line, but the value was changed. Go straight following the line to the end until the sonar value smaller than 15, and then continue, go straight until robot touch the object. It will fall back and stop left motor and the right motor, and lower the arm to pick. Enable car to catch the object and keep the object. Raise the arm, and the robot fall back, stop, and half turn and move forward. Just follow the line. Go back. Move forward, following the line until the end. Use sonar to find the end, and turn right to. At the end, change the way and lower the arm, lose the object, raise the arm, and the robot move forward to the start area and then stop left and right motor. Now let's watch the video for lab 3 I recording. First, the robot will turn left and go out the start point, find the line, follow the line to the end. The line was changed. It will it's not the easy line. It will change something some way. But I just use the line following sensor to follow the line. And then when it will touch the object and fall back and catch it. And go back for also following the line. Sorry, the laptop is a little slow. Use the sonar to find the wall and turn right. Now it's finished. Let's go. Here is some, I think it's important point, which what I learned from the lab 3. First is I set the global variables to control while loop, and this is I touched robot turns right if right line following sensors value larger than left one's value and the middle one's value larger than left one's value, turn right. Also the same as turn left. Reset variable TFB value if middle line following the sensor value larger than left ones and the middle ones larger than the right ones. That means the robot was go straight ahead, move forward, not mistake the way. So reset the variable, and this part is continue go straight, move forward until the robot touches the object. Reset the value for the variable. And this part is robot fallback. And this part is stop left and right motor. This is for the arm, lower the arm. You use move motor target function and keep 1,000 milliseconds. And enable claw to catch object and keep the object here. And raise the arm. When the arm was lower and catch the object and keep the claw and raise the arm. And the robot will fall back. And this is the object was catched. So first is lower the arm and then loose the object and raise the arm. Now I use these materials from the internet. Here I do the reference website for RobotC, for Robot Virtual Worlds, Carnegie Mellon Robotics Academy, and programming with RobotC, Introduction to Programming VXIQ, RobotC Intermediate Programming, Learn to Program the VX EDR Cortex in RobotC. Also, VX Cortex Reference, the guide. Summary. In the end, I met the problems during these labs. In the learning process, several difficulties I encountered are as follows. Now, first is, since the code is executed by the virtual robot, the same code will fail to execute for non-programming reasons due to host computer performance. It made me mistakenly think that there was a mistake in my code and wasted debugging time. After confirming it with the professor and the classmates, I realized that. So I ignore it in the future and just record the successful time. Try several times and record one time that I successful. Out of the lecture time, I have to find a lot of reference documents and instruction help documents on the internet to help me use different models of robots to execute the programs I wrote. Sorry. And now it's Q&A time. And thank you for watching my video. Thank you all.